Hello guys, welcome to our video tutorial series of operating system, and in this video I will explain about discussing process states, transition and signals in Linux. So in my previous video I had explained about the process states in Linux and how it's work, how its transition proceed from one state to another state, and in this video I will explain more about the signals of the transitions and how it's got interrupted using signals. So first of all, transition between processes I already explained many times, but will explain for our new users as well. So new to ready: when the process is created, the operating system setups all necessary sources. When the setup is completed, the process moves to ready state. So for example, if you open a Chrome browser or you just write a program, it will be safe in your secondary memory or hard disk. It will be in a new state. You just created a new state of your process. So once the CPU, and scheduler took your program from new state to running state, ready state, it will be like from secondary memory to your main memory RAM. So when a CPU is available and the scheduler selects the process for execution, it moves from ready to running. So once the scheduler set up and they create a new queue, ready queue, it will put your process in that queue. And then if the new process also started at the same time, it will also put in that queue, and the scheduler gives a equivalent time, or depending on the process priority, it will you know uh, ch- shift it to waiting and then again to the running queue. Every process has its own time depending on that process priority. So after running to waiting, the process need to wait for external event like when input output processes operations. It moves to waiting state. This transition happen naturally when the process makes a system call and cannot immediately complete it. So in that case, the process will be in waiting queue. Then it will go to the running to ready queue, and the scheduler decided to interrupt the running process to give another process a turn, because every process has its own turn. So you cannot run one process entirely again and again. Definitely the multiple processes run simultaneously, like multiple processes started together, like you open a web browser, you open a game, you open a window media player. So it will run simultaneously, and CPU scheduler decide which process needs to run first and then second, and then it will, it's like a life cycle. So after, if we want to stop a running process, it can be stopped by using a signal stop command in using. So I already told you about these commands signals in my previous videos. I will explain this in my this video as well. So the signal can be sent by user or another process sig stop. The process can then move to the stop state, then stop to ready. If they want to continue that signal, continue that uh, process, they just like sig count. It's sent to the stop process and it's like move back to the ready state again. So you can, stop and continue that process according to your choice, or the CPU decided, or the any other process decide. Then we have running to terminate it. When the process finishes task, it can terminate it by a signal like sig term, which means the process needs to be terminated, or sig kill, like the kill process. It moves to terminated state. Now we have waiting for ready. Once the event process was waiting occurs, like completion of input output operation, it moves back to ready state. Then we have running to zombie. When a process finishes execution but has not reported to exit states to its parent, it becomes a zombie state. This state is temporary state before the process is completely removed. Then these are the signals that we talk about in previous videos. Six stop, the signal stop a running process, moving it to stop state. So when you run this command or signal, it will, you know, stop a running process and move to a stop state. This signal continue if signal resume once you resume a stop process, moving back to ready state. Then we have signal terminate. So it can terminate a process. Then we have seek kill. It can forcefully terminate a process immediately, move it to terminate state without allowing to clean up our resources. So in seek term, it clean up resources before executing. Its seek kill is like a hard kill of that process. So how we used these signals in our operating system: seek int, interrupt a process using by control C, seek up, hang up or shut down or start process. One, seek kill the process cannot be ignored or caught elsewhere. It will kills forcefully. Seek terminate signal can be ignored or caught. It can be ignored or caught, but the seek kill cannot be ignored or caught. So it means if you type kill, seek kill, it cannot be ignored. It will, terminate that process. But if you use seek term, it can be ignored. Like we have multiple processes running, or maybe a hardware process, just ignore this, or the scheduler ignore this signal. So then we have stop signal, stop the terminal using the control C, like we use with the command prompt control C, and it will, you know execute our process. Then we have six stop. Six stop cannot be caught or ignored. It cannot be, once you type six stop, it can be, stopped. It cannot ignored by the computer or your process. So how is memory accessed during this transition? I already explained you in my previous video, but I will explain you about more. So primary memory is basically our RAM, which deal all these processes. When a process in a ready or running state, it primarily uses RAM for immediate execution and processing, and then transition like ready to running or ready to running to ready involve the scheduler manage which processes are loaded in RAM. During execution, the process accesses RAM for instruction data quickly. So once the process created, it will be in secondary memory, and then once it will be in the running state, and the scheduler, process loaded into RAM, and then it will create a ready queue, and then it will go to the uh, waiting state or running state again. Then we have secondary memory like our hard disk. When a process moves to running to waiting, or is swap or state may be stored in secondary memory to free some storage on RAM. This known as swapping. So this is how our hard disk works in during the processes. So paging involves loading part of process memory from disk into RAM when needed, allowing more efficient use of RAM. So paging is a technique in our programming or operating system. Is like use what you want, like if there is a thousands of data or processes, but at the time we just need to show like 50 processes, so we just paste that 50 processes first, and then after again 50, then 50, so it will take a less load on your system. So it same like paging involves in process memory, so it uses the RAM whenever it needed, so allowing more efficient use of RAM. If we load all the process into RAM, our RAM will be stuck, or maybe our program starts hanging, or our computer got stuck. So this is how paging involves. File access during waiting involves reading or writing data to seek storage, cause the process to wait until the operation complete. So There are so many other processes, like we create a program which read multiple files and read data from that files and print in our console. But it will create a huge impact on your hard disk, because when you are reading or writing a file, uh, our CPU schedulers and the CPU, memory, main memory, all the resources being used by these file accesses. So these are the two major effects on our hard disk: file access and paging. So understanding these transition and involved signal help manage how processes are handled by system, ensuring efficient use of memory and CPU resources while maintaining. So this is how signal works in our operating system Ubuntu. So this is how it's managed by Linux. So I hope you understand all the processes states in Windows, Linux, and obviously the signals, how the transition occurs in the processes between them. So stay tuned with us for next informative videos about Ubuntu operating system and Windows, and please share, subscribe, and like our video. Thank you.